Aloha, Rich Halverson here. This is ITS148. Today is September 24th. And let me share my screen. Here, share number 3. And so we are in ITS148, and today is this time right here. And so if you look at the syllabus, it's Gatorade someplace else. We are like right in here, chapter 10. And if we look at where we ended last time, I guess we finished up chapter 9, and then we did the chapter. We did lab. Oh, I used to. Okay, so I'm done here. Okay, so we are. If you look up here, figure 9.6.2. Did we do the? Oh, 9-13. Okay, so it's a lab 913. All right, that's what I did. That's how I ended it. Classes. All right. So anyway, let's look at the textbook. And this is where we ended. Okay, yeah, there were a couple more. Oh, there are a couple more classes here. Okay, so I'm going to leave those for now, and I can come back and look at those later if anybody would like me to. So I'm sorry, I guess I have not looked at the forums lately. And oh, there's some unread assignment questions. 620, yes, okay, Viz, okay, all right. So I'll look at those. Oh, yes, I know. I'm aware. Coming, it's coming. I haven't posted assignment 2 yet. That's right. It's due 9/26. Is that what it says? Oh. Okay, I will post. I should have. I will post this weekend. Okay. I did notice that this is here today. So, so anyway, I have to set up the Linux platforms for you. That's what's taking so long. Okay. And I got to set up accounts for all you guys. And then we're gonna do some simple assignment that you've already got working someplace else, and we're gonna get that running on Linux. Okay, so that's what the assignment's gonna be. So it's gonna be pretty easy. And when I get it set up, I'll demonstrate it, and then it'll be easy. All right. So let's go to assignment 10. All right, let's go to chapter 10. All right, so exceptions. See, this is 148. So you should know about exceptions already. And basically, these are constructs, statements that that Python provides for you to handle things that sort of go wrong, or things that can go wrong. And those things that can go wrong are exceptions. And like for example, if your program is for some reason dividing by 0, and that number is not able to be represented in the computer, so it's so your program can bomb. Or for example, when you're supposed to type in an integer and you don't type in an integer, you type in something else, boom, your program bombs. Anytime your program bombs, okay, that's an exception. That's an unhandled exception. And so what you can do if you want to is you can keep control of your program when those things happen. Okay, and you do that by putting in an exception handler. So if you're asking somebody to type in a number and they type in something that's not a number, then instead of the program bombing, you say, whoa, 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 you're supposed to type in a number, try again. And then, you're able to handle it that way, keep control of your program. Back when I started programming in the 70s and 80s, back in high school, the programming languages didn't have exception handlers. You had to, your program, if you wanted to, do something, or check if somebody doesn't type in a number when they're supposed to type in a number, you had to look at all the characters that were typed in, and you had to write a program to make sure that those were all digits that were typed in. So anyway, this is a very powerful thing that came along in the 90s when we started having classes and treating things like objects and so on. Normally you would just have the try part, and that's your code, and if it bombs, it bombs. But what you can do is you can enclose that code where it could possibly bomb. You enclose that code in inside of a try except construct here, and that's the try part. So if nothing ever goes wrong, then it's just the try part executes, it's done, and the program goes on. But if something did cause an exception, like the person didn't type in an integer when they should have, then it goes in and it jumps out, and the except part executes, and then it continues. Okay, so instead of it bombing in here, it jumps out and executes the except part. All right, so that's how exception handling works, and then the rest of this talks about there's categories of exceptions, and so your try except can have lots of excepts for all different kinds of things that can go wrong. Here's common exception types. There's an end of file error, which is your read. Oh, look, these are all the exceptions, it looks like. This is Python documentation here, and this is just an exception. And there's arithmetic errors that would be like dividing by 0, or it's possible to try to where you're doing a calculation and the resulting product of multiplying by 2 numbers is too big for the computer, so that would be an overflow error. So anyway, these are the common types that we deal with. This is an end of file error, which means you're reading from a file, like in chapter 12. We haven't gotten to there yet. If you're dealing with dictionaries, the data structure dictionaries, and with dictionaries you reference items by a key value, and if you try to reference a dictionary a key value that doesn't exist, then normally your program bombs. Well, you can put it inside of a try catch, and the exception can be on a key error. This is a dictionary key not found, and you can just say sorry, dictionary key not found, and then it goes on. Here's divide by 0. Here's some other kind of invalid type input mismatch or something, and indexed out of bounds. Okay, so anyway, so those are the kinds of exceptions, and you should click through section 10.1 because you do get credit for it. You do get points for that. And then the rest of these sections are reference because you've seen them before. And so this goes through examples of how you can fix a lot of this code, which does a lot of calculations where it's reading in, numbers, and it's got to be within certain ranges and everything, and how you can handle the incorrect inputs by using exceptions. So this is just all for your reference, because you don't get points for clicking through it. Here's multiple accepts. Here's a value error, here's a divide by zero error, and so on. And there's a hierarchy of exceptions also, which you probably need to pay attention to. Okay, I must have done this before. So you can go through this to make sure you understand the concepts. And so I'm going to get down to 10.7 here to actually do some stuff. Okay, raising exceptions. You can, without using exception handling constructs, and then here is using exception handling constructs. So if you like this exception handling way of dealing with bad input, then you can actually create and raise your own exceptions. So let's say that there's a valid input range. Well, okay, a weight has got to be greater than 0. It maybe should be greater than I don't know, some number greater than 0, 50 or something. But anyway, so this is how you can raise, for example, a value error exception, and then this is the message. So if somebody types in a height of -5 right here, then this happens, and it raises this value error exception. So then it skips out and executes this and tells the user to start over or something. So that's raising exceptions. So you can write code to raise exceptions. It's also useful for testing. Using exception handling along with functions. Okay, so your exception handlers be my example using exception handling constructs along with functions. All right, so so here you have functions that are outside of the try, and so they're out here, but these functions raise exceptions, because they take care of like reading in the weight and stuff, and and so there can be an exception raised in a function, and what's going to happen is, like in this one, then it was called by this one, and then so the exception is raised inside here, which causes and this is inside of a try, so it gets bounced out and handles the value error exception. There's an exception handler for it, and so it displays out this error if an exception is raised inside the functions. So that's all this is. There's this cleanup thing. And I've never really saw the value of having it because any code you want to execute whenever anything happens, you can just put it after the try except anyway. You can just put it after the construct. So anyway, I think it's just more like organizing. So here, for example, you open a file and you know, you do some stuff. If everything is successful, it's fine. And then when you're all done, you close the file. But you'll close the file no matter what, because here you open the file and any exception would here the file would have been opened, or there would have been an attempt to open it. It probably, you know, it didn't work here. So no matter whether this or this or this executes, the filing will be executed. All right, so anyway, so that's that. Custom exception types, and here you sort of can create your own if you want to. So here you're raising, there's a class, you can create classes of exception types. So anyway, that's interesting. Okay, let's try to do some of these labs. What time is it? It's 11:48. Boy, you got a lot of time left. All right, exceptions with lists. Given a list of 10 names, complete the program that outputs the name specified by the list index entered by the user. Use a try block to output the name and an except block to catch any index errors. So in other words, if you try to reference an element or an index in the list that doesn't exist, so if that happens, you want to output an error message. Output the first element in the list if the invalid index is negative, or the last element in the list if the invalid index is positive. Sure, okay. All right, so I'm gonna pull up a oh, should I use Visual Studio? Yeah, I'll use Visual Studio. No, I'm just gonna use an editor. It's easier. So let's see, this is me. Close this, close this. Where's my ITS148? Here we are. And what's inside here? Oh. I'm gonna do a oh, this is a particular lab, 10.7. So I'm gonna do a 10.7. First, just let me open up something here. Open up here. No, open it up from here. Open desktop 148 test.py, and whatever this is, I'm going to do save as 10.7. 10.7.py. And I'm going to get rid of everything. And I'm going to start with this. Copy, paste. All right. So I'm supposed to, oh, I have a list like this, okay. And I input an index. And so I input an index, I read in an index. And then Oh, I'm supposed to put it all in a try catch, huh? Got it. Okay, so try colon print print name colon this dot format its names index. Okay, now I'll tell you what this is as soon as I'm done with all these parentheses. Okay, so so this is a list, and this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what this is going to do is this is going to print out, you know, the index, or the index, the name at the index that was read and was entered by the user. So if we first start out doing this, yeah, let's just do this, very simple. So let me open up my command cmd cd OneDrive / desktop / ITS148. Okay, so there we are, 10.7.py. So I'm gonna do I'm gonna enter an index. Okay, save. I'm gonna do Python 10.7.py. Enter an index. Okay, so if I enter in like 2, I should get Reagan. 2, have a niece named Reagan. Okay. However, if I enter in -1, it goes Johnny. Oh. You know what it's doing? It's giving me this one. So it's actually because you can reference the last item by doing -1. So all right, so that works actually, but we want it to be where it says it's, wait, what do we want it to do? We want it to say, oh, wait a minute. Okay, 5 does Jane. Let me run this. 5 does Jane. 12 does okay. Okay, I see. What is -2? I see. What's -2? God. Okay, so it is working right. So if I enter an index that's outside the range, which 15 is outside the range. Right now, I enter 15, and what happens? It goes, bung, index error, dan, list index out of range. Well, we want to catch that in C#. It's called try catch. In this language, it's called try except. So what we do is we're going to put it inside a try except. So try doing that. Otherwise, if there's an error, don't accept index error. And I'm going to name it. So I'm going to name it EX. I'll just name it EX. And so then I can print out whatever it is. is, and I got to do whatever format, and I'm just going to print it out. Printing out whatever this EX is, and it's going to be some text. It's going to tell me what the error is. All right, so that's so now it's going to do that instead. So it won't print out an error. Wait a minute. It is going to, hold on. Let's run this and see what it does. Okay, I'm going to say 15 again, and it goes, exception is list. The exception is it's this list index out of range. That's what it displayed out. I should put a colon here. All right, so all right, so but what we want to do is if it's 15, we want it to display the closest one is this one, and that's Johnny. So this is dumb. So what I want to do is if the index is greater than the length of the, okay, well, if it comes here, it's either because the index was too high in the negative or too high in the positive. So if the index is less than 0, then that means that it was like minus 10 or lower. So an exception occurred, so that's why we're here. And it's going to either have occurred on a minus number or a positive number. And if it's a minus number, I want to return this one. And if it's a positive number, I want to return this one. Basically, that's what it is. Okay, so this tests if it was a minus number. And if that's the case, I want to print names of 0. And otherwise, I want to print I can't remember how to find the length of the list, but I do know how to print the last element of the list, and that is this. There, how's that? That'll print the last element. So let's try this. Okay, so if I do positive 15, it says exception is in list index out of range, and Johnny. Okay, so Johnny is the. So I'm going to say something like. Is the first element. And here I'm going to say is the last element. I should say what the highest index is. All right, how do I find the length of an index? Length of Python size of list, length of list. It's called len, I think. Len. So I can do I'm gonna do this at index last index, and I'm going to say last index NDEX equals len of names minus 1. So let's see what this does. Oh, this has got to be indented. All right. 15. Yeah, Johnny is the last element at index 9. If I just do minus 15, though, it's going to say Riley is the first element. All right, so anyway, so you have enough to do this problem. This is what happens when you type in a negative number, and this is what happens when you type in a positive number outside the range. I got fancy and decided to display out the last index and everything. So anyway, that's that. You should be able to do that one now. Let's do the next one. But we're going to get through all these. Simple integer division, multiple exception handlers. Oh, good. So write a program that reads integers this one and this one, and outputs the quotient. Use a try block to perform all the statements. Use the except block to catch it, a zero division error, and output the exception message. Use another except block to catch any value error caused by invalid input and output. And output an exception message. Okay, so if we find an invalid input, then we output an exception message. Okay, so divide by 0 is thrown when a division by 0 happens, and a value error is thrown when a enters a value of a different data type than was defined in the program. Do not include code to throw any exception. Okay. All right, so reads in two numbers, and it should display the quotient, which is this number divided by this number. Displays this one. This is the dividend, and this is the divisor. And if the divisor is 0, you can't divide by 0, so it outputs this thing. Okay. I think this is produced by the Python runtime machine. And then this is a problem because it's expecting an integer. You see it's using this, and you can't have a period in there. All right, so we're supposed to write our code here. We're just supposed to write a program, huh? Well, okay. All right, so I'm just gonna save as 10.8. And get rid of all this. And so I guess I'm gonna okay, so normally my code would be like this. Read in user num. So I'm gonna write the code first without the try catch, and then I'm gonna write the code with the try catch. Then I'm gonna add the try. I'll add the try except after I write the plain code without the try except. Okay, so user number, and so I'm reading in an integer, and I'm asking for an input. And what am I asking for? I'm asking to enter a dividend. Okay. And what's the other one supposed to be called? Divnum. Divnum. Divnum equals integer of input enter, why does it do that? Enter a divisor. And then I'm just going to do quotient equals user num, and I can use this integer divide thingy, and that'll just give me the integer part of division. Guess I can do it that way. Anyway, and then I want to print that out. Print out the quotient. Okay. Okay. So now, if we run this, I'm going to run 10.8. Enter a dividend, and so I'm going to do 15. Enter a divisor. I'm going to do 3, and it says 5. I'm going to write that out. Quotient is, there we go. Oh, I don't need a space to do it. Okay, so now if I go do it again, enter dividend 15, 50, divisor of 0, and bung, it doesn't like this. It raised an exception. Okay, so that's bad. And then the other one is running it and enter a dividend, and I'm going to enter in 5, F-I-V-E, bung, invalid literal for int, for the int function. Okay, so this it didn't understand this. So these are the two kinds of exceptions. There was a 0 division error and a value error. And what we want to do is we want to put it in a try except and catch these exceptions when they are raised and keep control of our program, write out a nice error message and let the program continue. You know, we could have this in a loop or something, in which case it would just go back and ask the user again if an exception happened, but that's okay, we can do it this way. All right, so so how would it work? Well, first of all, I do like this. I'm gonna put a try up here, try colon, and this gets indented, and then I do an except, and I guess I put the name of the exception. Now, what happens? I wonder if it matters the order. I guess it only matters if there's like a, well, okay. So anyways, so I'm going to do the value error first. Okay, so if there's a value error, in other words, they typed in F-I-V-E instead of the number 5, and I'm going to call that X for exception. How about X message, X MSG, exception message? How's that? If it's this error, then I'm going to say print please enter a number or some such thing. Okay, and then I'm going to do comma EXMSG just to see what they say. Okay, so that's that error. And then I'm going to also add the except the divide by 0 or 0 division error. And I'm going to have that be also X messages fine as a fine variable name for that. And I'm going to say print don't enter 0 for a divisor, comma, and see what it says. All right. So this says it's able just to go on and do the next thing. All right, so let's see what this looks like. All right, I'm going to enter a dividend of, first I'll do it the regular way, 5, 3. And it says quotient is 1. Have a good day. All right, let's run it again. And I'm going to do 50, 0. Don't enter 0 for a divisor ever. Integer division or modulo by 0. Have a good day. Okay. One more time. Let's do 50, and I'll enter in O-N-E for 1. Please enter a number. Invalid literal for int base type at 1. Have a good day. Okay, sorry. Right, good. All right, so you can you have everything you need to know to do that one. Let's see. Here we have, is this a very hard one? Oh, the last one looks pretty hard. A pedometer treats walking 2,000 steps as walking 1 mile. Write a steps to miles function that takes the number of steps as a parameter and returns the miles walked. The steps to miles function throws a value error if the method says negative step. Can't have negative step counts. Complete the main program that reads the step counts from the user, calls the function, and outputs the return value. Use a try except block to catch any value error thrown in here. All right, so it sounds to me like we want to have a function that can raise an exception, can raise a value exception, value error exception. And so testing that the parameter is a positive number is done inside this function here. It's not done outside the function. All right, so and we're going to print out the output the floating point value with 2 digits after the decimal point, like that. So if you enter in this, it's going to print out this many miles for this many steps. If you enter this in, it's going to say, sorry, you can't. Walking backwards is a different formula or something. All right, so we have to write our code here and write our method here. Well, we can start by writing a method. And how about name it steps to miles. And so it's going to bring something in. Does it tell me what I have to name it? No, it shouldn't tell me what I have to name it. It shouldn't matter. But I name it on the inside. So I'm going to call it steps. Okay, and if steps, and here's where I raise the exception. If steps is less than 0, then raise a value error saying, I realize you are just testing. Okay. Otherwise, I go ahead and I calculate what the steps is. Miles equals steps divided by 2,000. I think that'll work. And then I want to return miles. So that's that. And here I want to read in some steps. Read in some steps. Input, integer, input, enter steps. So I read in some steps, and I print out. Oh, I was just going to say, I guess I can print it, huh? So miles equals steps to miles, steps. Okay, so that's gonna do something, and then it's gonna have this, and then I'm gonna print this out. Print. I'm gonna print it out this way. Oops, yeah, that's right. Okay, and it's not your value, it's miles. Okay, so this is some code, and I don't have the try except part in yet, but let's see if this works. Well, let me just copy it over here. Copy, and this is 10.9. This is 10.9. Save as 10.9. And if I run this, 10.9, I get to enter some steps, 3,500 steps, 1.75 miles. I should say something like that. Is that how they want me to print it out? Huh, okay, well, easier for them to test it. Comma, miles. There we go. And 5345. Let's see what happens when I do that. 5345. 2.67 miles. Yep, that's what came out. And now if I go enter steps, 1000. Invalid literal. Okay, so it didn't like that value error. And then another thing I can do is minus 3,4,500. Okay, so here it actually displayed out the value error that I entered in, because I wrote code to detect if this is a negative number, and if it is a negative number, I raised this exception, and this was the error message that I put in. See? So anyway, we want to capture both those, and so we would put that down here, and so that would be down here. So I'm going to do a try colon, enter, and then I'm going to do except value error as, and I'm going to call it EXMSSG, print Value error message. EXMSG or some crazy thing like that. Now, what does this do? All right, let's see. Enter steps 1000. Error message, invalid literal for O. I have to make it clear that life goes on. Print life goes on. Okay, so actually what I should have done is without the try except, I should have put this in before. In fact, I think I will. Wasting time. I know, wasting time. Okay, so this is before I put the try except in here, and then I put, and then here I'm going to print life goes on. And the point is, when everything works fine, you put a 3500 and it says, when everything works fine, it prints out life goes on. But otherwise, but if you don't do it right, 3500, it says it raises the exception and the program just terminates and it does not print life goes on. Similarly, if I go minus 3500, it raises the exception because I do that here, and it bombs. All right, it's done. So it does not print this in both cases. But when we do the try except, try except value error as some message, I can print in here. I'm going to print a print value error, comma, and then I'll print that message. That, and so now what happens here is when the exception is raised, it doesn't like something. I forgot to close the quote. So enter the steps. I go 3, 5, capital O, and it says it raised the exception, says what the error is, and then but it finishes. It says life goes on. If I enter in minus 3500, it says value error. I realize you're just testing. Okay, that's because that's what I say here, and then it finishes. So there's an error caused right here. There's an error. The exception is raised in this thing, and then it bounces out and executes this, and then continues. All right, so that's 10.9. All right. There's only 5 minutes left, and 10.10 is a biggie. Okay. So let's see. Should I do like? No. Okay. All right. So I think I'm going to end it. So I think I'll end the class now, if that's okay. 5 minutes left. So next time I will figure out how much I'm going to help you with 10 and 10.9 or 10.10, but maybe that will be one of these. I got to figure out some problems that I'm going to give you that won't be worth very much as far as your grade is concerned, but can be used, and I can repeat them semester after semester, so I can try to assess my improvement at teaching these concepts. And we're supposed to try the accreditation folks. They're really into assessment now, and they're having us try to assess ourselves in new and better ways. So anyway, I will see you next week, and we'll probably only need to have one class again next week. I might schedule two. But anyway, if there are any questions, great. I will see you next week. Take care.